So inscribed angles are a different kind of angle than central angles. All right, so yesterday we talked about central angles that have the vertex in the center. An inscribed angle has the vertex on the circle. Okay? So this angle, ABC, is an inscribed angle because the vertex B is on the circle itself. It's not in the middle anymore, it's somewhere else on the circle. So inscribed angles kind of go all the way across the circle. Okay? Yeah, I mean, I don't know what I left blank there for you. Okay, so you are filling in both of these.
I know, but it says on the circle, comma, and, with the and. What is that for?
And this.
Oh.
Okay, I mean, if it doesn't make sense, you don't have to put it there, but. Okay. So the vertex of the angle is on the circle, and then the sides of the angle both have to intersect the circle somewhere. So all that means is you can't have one side of the angle like shooting off this way. Okay, they both have to somehow go and be on the circle someplace themselves. Okay, and you can abbreviate that in a way that makes sense to you. Isaiah, you got that written down?
Yeah.
Okay.
Thanks, man. Appreciate that.
Guys. So with central angles, the measure of the angle matched the measure of the arc. Do you think that's true here?
No.
Anyone have a guess?
It's 3 times.
You think double? You think 3 times?
Okay.
Okay.
4 times.
Okay. The measure of an inscribed angle is half the measure of the intercepted arc, which essentially is double. I mean, it means that if you've got this angle, that the arc is double what the angle is. Just depends on how you're looking at it. If you're going from arc to angle, you cut it in half. If you're going from angle to arc, you double it. Okay? So the arc is twice as big as the angle. How many degrees are in a semicircle?
180.
180. Okay, so if you inscribe an angle inside a semicircle, what's the measure of that angle going to be? 90, because it's going to be half of 180. Yeah. Okay, so if this arc was 60, this angle would be 30. All right, if it was a 180 degree arc, half of that, if you were to do an inscribed angle, would be 90. That's our next slide. What is the measure of an angle inscribed in a semicircle? Okay, an angle inscribed in a semicircle is always going to be a right angle. All right, because if you were to go from A to C, that's halfway around the circle, so that's 180 degrees. This angle that's inscribed in that arc would be half of that 180, so it would be 90. Easy concept, right? That's really the only new concept you're learning today. Okay, now we're just going to practice a bunch with that. Okay? Yeah, tangent is tomorrow. Okay, so if you have that this arc is 150, how would you get the measure of this angle? Divide by 2, right? So it would be 150 divided by 2. Actually, I'm going to make my pen a little thicker here.
75.
150 divided by 2. Yep. I'm writing this in here just so if you look back later, you remember how you got that. But it would be 75. Let's try going the other way. If this angle is 50, how do I get the arc?
Where's that one? We don't have that one.
What?
Oh, is it on a different slide?
Yeah. No, but else.
Okay.
It's okay, guys. It's okay. You do 50.
So now I'm looking at this one, right? Okay. So arc TW means I want this arc. Okay? What would be the measure of that arc? 100, right? Because it's going to be double the angle. So I can put that down here too. This is 100. What do I mean when I say arc TMW?
The first goes to T, then it goes to M, and then it goes to W.
Okay, so it goes the other way around the circle, right? How would I find that? Yeah, there's 360 total. I know this little piece is 100, so I want everything except that. It would be 260. Not bad, right?
Right.
Okay. Let's
Okay.
is this which, maybe this one is your next one?
Yeah.
Okay. Okay, so that one is back on example 1 and 2. This one down here is what I'm looking at. Sorry, mine must be on a different order than the student one. Sorry. Okay, so if this is 180 degrees, this is a semicircle. What's that angle T? 90. Yeah. Okay. Angle T is going to be half of that 180 degrees. These are the ice cream cone problems. They all look like ice cream cones. Okay, do you have this one? Is this one your next one? Okay. Okay, so let's take a look at this one. You've got that this is 180 degrees, that this is 100 degrees, but what I really want to know is this angle, which means I really want to know this arc. How do I get this arc? Bryce.
What'd you do?
You've got it.
180 plus 100 and then subtract that from 360.
Okay, so we're going to take 360 and subtract the 2 that we have. You're right, we could also add those together first. Basically, I'm going to subtract 280. Okay.
I apologize.
And I should get 80, I believe.
Yeah.
So that means the measure of this arc here is 80.
Couldn't you just see how it's 180 right there and 100 right there?
Yeah, you could say the other half would have to be 180. Sure. Yep. And then, so what would angle Y be?
40.
Half of that, yeah. So then you'd have to do 80 divided by 2 to get 40. Okay, 40 degrees.
Why do you have to divide it by 2?
Because to get the angle, remember the angle is half of the arc. Okay? So it all depends on what it's asking you for. Just be careful with that. Are these right for your next two?
Yeah.
Good. Okay. All right. I like this next question. Okay. Angle M is it inscribed or is it central? It's in, wait, angle M is inscribed. Okay. So angle M is going to be half of this arc measurement. But I don't know what that arc measurement is. Or do I?
Yes, you do.
What would it be?
88.
It'd have to be 88 because it matches with this central angle, right? So this arc would have to be 88 because it's the same as the central angle, which means angle M would have to be 44, yep. Okay. How about the arc, the measure of arc VY?
I'm guessing.
Any thoughts about this?
Is it 140? Oh,
It-
actually.
Let's see. That, nope, I don't think so.
I see something.
Okay, what do you see?
You see how Y, and you see how X like cuts it, angle X cuts it like in half?
Mm-hmm.
So it could do alternate interior angles there?
Almost. I guess what I should point out here is that angle X is supposed to be the center of the circle. That's what was missing there. Okay, X is supposed to be the center. So here's what you could say, and let's see, I want to think about the most direct way to do this.
Wouldn't it be 140?
It would be 140, yep, once I put that X was the center. How do you know?
Because one is like one from Y to X is 70,
Okay.
and then you just practice it to do this.
Okay, so that 70 being there means that, okay, if this is my angle, that this arc would be 140.
And it's the other half.
So somebody justify to me why this one on the bottom would be 140. There's a lot of different ways to do it. I could think of like 3. That's why I was trying to think of the most direct way. Okay. But why does that work for the bottom arc? Okay, because of the central angle? Actually, that's not good. Rihanna, what were you going to say? Okay, but do we know these other
I
arcs?
think you're right.
We could get there, but... Okay, I'm going to go with what Adam was saying about the central angle. If this is 140, isn't the measure of this angle 140? Right? This central angle here would be 140. So what's the measure of this angle down here?
140.
How do you know? Vertical angles. And then wouldn't the measure of arc VY also be 140?
Yeah.
Okay, so that would be one way to go about it. The other way I was seeing is that, what kind of triangle is this right here? Nope.
Triangle.
It would have to be isosceles because this and this are both a radius, right? If they're both a radius, they're going to have the same length. So if this is 70, then Z would also be 70. And if you look at Z, Z is inscribed in that arc down there at the bottom that we're looking for. Okay? So you could go about it one of those two ways, or maybe a combination of the two. Rihanna had suggested subtracting from 360. That could work if you found these angles, but you could if you found what these central angles were. So you could do that too. Okay, so lots of different things you could do with that one. That's what I like about circle problems, is there's usually a lot of different ways to get to the same answer. There's a lot of different ways you can go about something. Okay, draw a circle with center Z. All right, so let's label our center Z. That has an inscribed angle TUV. So I'm just going to pick 3 points anywhere on the circle and name them T. Well, we're going to pretend that's on the circle. U. V. Let's draw that angle in. Okay, it could go through the center, it doesn't have to. And arc TV is 80 degrees, so this arc here is 80 degrees. And then it says label everything appropriately. Well, the only other thing I can really see to label would be angle U. What would angle U be?
40.
Yep, half of that, which is 40. Yeah, that one wasn't too bad, right? Just seeing if you can follow directions. Was that the end of what I had for you there?
Yeah.
Okay. Yeah. You know what? Actually, Travis, you might want to stick around for just a second. I have one more thing I want to show you that's going to make your life a little easier. You just want to follow along. Okay. This probably has a theorem name. Do you need to leave, Nick?
Yeah.
I don't know what time it is.
Did you have to leave 5 minutes ago, or do you have to leave in 5 minutes? Leave right now. Did you say you had
Okay.
to leave at 2:35? Isn't it 2:30? Isn't it 2:30?
Let's say I inscribe. Isaiah, will you have a seat?
Oh, yeah.
Let's say I inscribe a quadrilateral inside a circle. Okay, quadrilateral means 4 sides. So I'm going to do this, and this, and this, and that. Okay? And I know nothing about those side lengths. Okay, I don't know if any of them are congruent. I don't know if this is a parallelogram. It's just a quadrilateral. Do you see that this angle intercepts this arc, right? So this angle up here is going to be half of whatever this arc is. I don't know what that arc is, but it's going to be half of it. And if I look at the angle right across from it, if I look at this angle intercepts this arc. So that angle is going to be half of the green arc, right? Does that make sense? What do the blue arc and the green arc make all together? 360, yeah, because that's the whole circle, right? The green arc is on the top, the blue arc is on the bottom. So the two arcs together make 360. So if this is half of this one, and this is half of this one, would you agree that the two angles together are going to be half of the circle? Let me say that again. This angle is half of this arc. This angle is half of this arc. When I put the two arcs together, I get the whole circle. So when I put the two angles together, I get half the circle. How much is half the circle? 180. So there is a separate theorem that goes along with inscribed angles that says in a quadrilateral like this one, the angles that are across from each other will always add up to 180. Okay? Let me jot that down for you real quick. In a circle, opposite angles are supplementary, which means they add to 180.
They'll do it always.
Always, as long as it's inscribed in a circle.
As you-
Okay, so as long as all the corners of the quadrilateral are on the circle, which means I could do that same thing with this angle and this angle. Is I could say, okay, from this angle it would be this arc, from this angle it would be this arc. Together that makes the whole circle. And so since both angles get cut in half, it would end up being half the circle, or 180 degrees. That's just going to give you a shortcut on a couple of your problems on your homework. You could have done the assignment without knowing that, but it's just like I said, a shortcut for you. Okay?